Hello, today in this video lecture we will see this simply supported beam, free body diagram, shear force diagram, bending moment diagram by using manual calculation, StatPro software and thumb rules. So first understand this beam. This AD beam is total 2 plus 3 plus 5, that means 8 meter span simply supported beam. At A there is hinge support, that means two reactions AX and AY. This second diagram is free body diagram, and at point B there is inclined load with horizontal it is 35 degree and this load is 50 kilonewton, and between C to D there is 20 kilonewton per meter uniformly distributed load acting on 5 meter. So we need to resolve this inclined 35 degree load into two components, one vertical component and one horizontal component. That means this is 50 sine of 30 degree, that means it is 25 kilonewton, and horizontal load is 50 into cos 30, it is 43.30 kilonewton. So our first step is to judge this beam and judge shear force diagram. So first understand this beam. See, center of this beam is 8 meter, that means center of this 10 meter span beam, this is not 8 meter span beam, 10 meter span beam. So center of this beam is somewhere here. This is not to scale diagram, so center is somewhere here. And see, more load is towards this dy reaction, because here it is 20 kilonewton per load and here only 25 kilonewton load, so more load is towards this dy. That means here maximum shear force comes at point D. Why maximum at point D? Because load is maximum towards D point, and this AY goes upward, that means this is vertical shear. Between A to B there is no load, that means horizontal line shear force diagram suddenly drop and 25 kilonewton drop, that means like this. Between B to C there is also no load, so again inclined line, and between C to D there is uniformly distributed load, that means here is inclined line like this. So now bending moment diagram judgment. Bending moment is also maximum here where shear is 0. So this is pin support, that means bending moment is 0, and between A to B there is no load, that means bending moment is inclined line. Like this. Up to point C there is also no load, that means like this. This is A, B, C, and here uniformly distributed load. That means bending moment is parabolic curve. So this is like this. Maximum bending moment is here. So this is our judgment only. Now we need to calculate exact values. So for that, first equilibrium with y, summation of fy equal to 0. This is ay plus dy minus 25 minus 100. Here concentrated load acts at mid 20 into 5 100 kilonewton, and from d it is 2.5 meter. Ay plus dy minus 100 minus 25. Ay plus dy is equal to 125 kilonewton. Now we need to calculate ay or dy. So take moment at this dy. Clockwise movement positive, anti-clockwise movement negative. This is clockwise, that means positive ay into 10 minus 25 into 8. This is anti-clockwise 2d. This is minus 100 into 2.5. So ay is equal to 45 kilonewton. Put this ay in this equation. Dy is equal to 125 minus 45, it is 80 kilonewton. That means we had calculated dy and ay. Now we need to calculate this ax. Take summation of ax is equal to 0. Positive ax positive 43.30. That means this ax is minus 43.30 kilonewton. So reaction calculation is complete. 43.30. So this arrow is value is negative, that means this arrow is towards negative. value is 43.30 kilonewton. So next step is to calculate shear force values. Shear force diagram. First shear force at A is this reaction 45 kilonewton. Next is shear force at B is 45. There is no load in between this. That means this B towards left and towards right. Towards left is this 45 kilonewton because there is no load in between this. So shear force at B towards left is similar 45 kilonewton. And shear force at B towards right is this upward 45 kilonewton minus downward upward 45 minus 25. That means 20 kilonewton. This is 45. This is 20. A, B, C, D. Now at point C towards left and towards right. Shear force at point C towards left is similar 20 kilonewton because no load in between this, and shear force at C towards right is 45 minus 25, and so it is inclined line due to this uniformly distributed load. Towards right, so we directly calculate shear force at point D. Shear force at point D is plus 45 minus 25 minus 100. Plus 25 plus 45 minus 25 minus 100. It is minus 80 kilonewton. This is towards left, and shear force at point D towards right is this dy reaction 80 kilonewton. So values are 45, 45, 20 minus 80, 20. So this is, here it is minus 80 and here 0. So this is shear force diagram. This is positive, this is negative. Now we need to calculate bending moment. So bending moment at A is 0 due to pin support. Bending moment at B is this AY into 2. AY is 45 into 2. It's 90 and unit is kilonewton meter. Now at point C, 45 into 5 and 25 into 3. 45 is clockwise and 25 is anti-clockwise. That's why minus and plus signs. This is 150 kilonewton meter. Now bending moment at D. D is also roller support, that means it is 0. So 0, 90, 150. Here it is 90 kilonewton meter, and here at point C it is 150 kilonewton meter. Now we need to calculate this maximum SFD now. So for that, consider this as a X. So use easy way. Take this section X and consider bending moment is equal to 0 there. Maximum bending moment. Consider this as a section YY. So this is positive convention. Let's assume this as my. Clockwise, that means positive my. And this is, we need to calculate moment at this point. And here it is 0. So positive my. This is also positive, plus 20x into x by 2, and this dy is negative. Dy reaction is 80 minus dy, that is minus 80 into x is equal to 0. And here moment is 0. This my is also 0, because see, no moment, no, this is moment is acts on this. So this moment is not 0, shear is 0 there. So my is equal to 80x minus 20x square by 2. I think for calculation of x, first we need to consider shear 0 there. For calculation of x, where this shear force is 0, we don't know where shear force is 0. See this diagram. This is in between C to D. We judge that this is in between C to D, thus, but we don't know where actually it is from D point. It is 2.5 meter or where. So let's assume this as Vy. Upward, that means positive Vy. 0 shear. So positive Vy minus 20x and plus 80 equal to 0. So positive Vy is equal to 20x minus 80. And this Vy is 0 there. 0 is equal to 20x minus 80. So 80 is equal to 20x and x is equal to 4 meter. So we calculate that shear force is 0, 4 meter from D point. That means from A point it is 10 minus 4. That means it is 6 meter. So now we need to calculate bending moment, maximum bending moment. So maximum bending moment is equal to this my is positive. So and this my positive is maximum. This 20x into x by 2. This is also clockwise. So 20x into x by 2. And this is anti-clockwise, minus 80 into x. And equal to 0. So this my maximum is equal to positive 80x minus 20x square by 2, and where shear is 0 at x is equal to 4 meter. That means bending moment is maximum at 4 meter, and it is from D point. So put 4 in this x value. 80 into 4 is 320. 20 into 4 square by 2, 160. 320 minus 160, it is 160 kilonewton meter. That means our judgment is correct. This is 160 kilonewton meter. Now this same problem we will solve by using STADPRO software also. We directly put this 25 as vertical load. So this is 2, 3, 5. Now we will see this SFD and BMD in STADPRO software. So our beam total length is 10 meter. So this is define some properties. These properties are for dead load purpose, but we will only interested in live load bending moment calculation only for that 25 kilonewton load and that 20 kilonewton per meter load. At point A it is pin support, that means Fx Fy, so only Fx and Fy reactions are allowed. See isometric view, only Fx and Fy are allowed. Okay. Today bending moment calculation, these all are released. So this support 2 is this. Now next is only vertical reaction is allowed at point D. So this is support 3. So loading 25 kilonewton per meter load at 2 meter. So assign this. And this 20 kilonewton per meter is in between. D1 is D1 is 5 and D2 is 10. So analyze this beam. Something is error. Error elastic modulus not enter for member. So let's concrete. Assign to view. Assign yes. Property. Delete this property and again define. Elastic modulus, modulus of elasticity, ratio of stress upon strain within elastic limit. Hooke's law. It is material property, elastic limit. Again, error, why this error? Error elastic modulus not entered in the member. We are not interested in materials, so let's consider this as aluminum. We are only interested in live load bending moment. So now check what is reaction. Yes, now see, at point D it is 80 kilonewton and our manually calculated is, see, this is 80 kilonewton. At point A it is 45 kilonewton and C at point A 45 kilonewton. Now check shear force. In order to annotate shear force, you must have shear force FY diagram on. Please switch on diagram. Now on, turn on beam result. Okay, FY. We are interested in FY. So see shape of this SFD similar to our shape. Annotate beam result, shear maximum mid. Annotate. So see 45 kilonewton, 20 kilonewton and 45 20 and minus 80. So it match. Again see movement. Zero 150 159 0 150. See 150 kilonewton 159, that means it is 160. See our bending moment is positive, sagging, but STAD tells us that negative is sagging bending moment. So this is difference. Our manually calculation is positive value is sagging bending moment, but STAD negative bending moment is sagging bending moment. Remember this. And shear force notations is all are correct. Sign and values are also correct. See displacement. See at 5 meter displacement is minus 1.9 inches. So this way our shear force diagram and bending moment diagram completes. Thank you very much.